Okay, with our test coming up this coming week, I thought I'd make a series of little videos to try to help us kind of review, since our time is very, very short. It's been a really long time since some of the stuff was studied because it's covering about 6 weeks worth of material. So the first thing I thought we could study today is quadratics. It's been a little bit since we did that, so let's just jump right in there and let's look at, in fact, before we do quadratics, let's do it with inverses. So what we did with inverse is if we had a function, a simple one like this, a nice little cubic, 2x plus 1 cubed minus 1. Just a quick reminder, remember that we said we would switch x and y. We would go like this. Notice I swap x and y, and then my big goal is to go ahead and get y by itself. And this is not evaluating, it's solving. And when we solve, we don't do PEMDAS. We actually do PEMDAS in reverse. And so as such, we want to code this way. So the first thing I want to do is get rid of any adds and subtracts. So that would be x plus 1. Now, I do know some of you could go a little bit quicker than this. So now I got rid of my multiplies and divides. Now I want to go ahead and get rid of my exponent. So to get rid of my cube, I'll take the cube root. And last but not least, we're going to move the 1 across. And so my final answer is that the inverse of f is the cube root of x plus 1 all over 2, and then minus 1 right here. This is my own style. I like to put a little tag at the end of the root just to emphasize that the root is over and this minus 1 is after. Now, one thing I would like to mention here is if we wanted to prove that we were right, that's actually a very important thing to be able to do, that you will be required to do on your test. So if I have done it right, if I took f of f inverse of x, we should know that that's x, which means literally that f of f inverse of 5 is 5, or f of f inverse of 2 is 2. So any value of x that I picked out, I'll get that same number. So I noticed that on our quiz, a couple of you guys went way too fast, and I docked you for that. So if I want to do this, I'm going to plug in the inverse right here. I'm going to change colors to emphasize that all of this stuff right here is, in fact, the inverse. So the first thing that I noticed is the negative 1 and the positive 1 did, in fact, cancel out. And it does get tough to show all the steps because it is kind of becomes obvious. Notice the cube and the cube root do in fact cancel yet again. I notice the divide by 2, the times 2 cancel, and I have x plus 1 minus 1 is in fact x. So that proves that we did the problem right. Now, one thing that I would also like to mention is that we can also look at our graph, look at it visually. And so I have a Desmos sitting here ready to go. So in this Desmos, I have my little cubic equation right here, and my x, I jumped in too quick. Here comes my original equation, x cubed. And then this is the inverse that I found, and there's supposed to be a reflection across y equals x. So a nice thing to look at is something like if I plugged 1 into x, notice that y becomes 15. Desmos doesn't allow me to use inverses, so I called it G instead of F inverse. But if 1 gives me 15, then 15 should give me 1, and it does. Or if 0 gives me 1, then 1 and the other one should give me 0. So that kind of confirms that I did a good job. Okay, so I've got that one down. So what I'd like to do is one more. So instead of just dealing with a cubic, let's look at one quadratic, and that's going to bring something up that I did tell you I was a little bit concerned about. So when it comes to quadratics, here's a simple quadratic. Again, I'll call it f. In Desmos, I'm going to use a slightly different number, or different name, excuse me. So I'm going to do my little switch of x and y. This is kind of what most math students do. They kind of just put their head down. They have a process that they follow. I move the 4 across. I'm going to divide by 5, just slowly doing PEMDAS in reverse. Of course, take the square root of both sides. Which leads me to something kind of interesting. Over the last couple of days, I've emphasized in class that every time you take the square root of both sides, you're supposed to get a plus or minus. But in this case, we don't do it for a very particular reason. And you may or may not remember what that reason was, but I'm going to address it in the next little piece of this. So notice again, what we would have is this is called F inverse, which should be the exact opposite. So you'll notice the +4 in the question, the -4 here, the +2 with the -2, the ×5 divide. You can see all the remnants of those things. So let's take a look at what Desmos does when we actually look at that particular story. So I'm going to open up my quadratic right here, and I have it saved, but I do want to look at something first. The problem that I have is in line 1, if I do my original problem, and I go 5x plus 2 quantity squared minus 4 is y. So notice we have a simple little story. But if I go ahead and I do what we talked about in that first line, which is swapping x and y, this should just illuminate a problem that we have that you may or may not have remembered, and that is that you cannot take an inverse of a function that is not 1-to-1. And this function is definitely not 1-to-1. So before we proceed with that problem, let's go ahead and fix that. So back to our work. I know that the vertex of this problem right here is at -2, -4. So if I want to make this graph 1-to-1, I need to ensure that it passes both the vertical line test and the horizontal line test. So what I'm going to do is I'm going to make my new domain to be greater than or equal to -2, with my range being greater than or equal to -4, which means down here, remember, domain and range flip, which means now x is going to be greater than or equal to -4, and y is going to be greater than or equal to -2. So now let's go back to what we had in Desmos and see if we did okay. So I'm going to kill these two things right here, and I'm going to open up my quadratic right here. So my original question was this. And understand, again, we have a little bit of an issue. So I'm going to change the domain of that problem to be greater than or equal to -2. And so now you notice that the graph is, in fact, 1-to-1. It passes the vertical, it passes the horizontal line test. Notice when I flip it over, you see this nice little simple symmetry. And then you could check it, and you could try some numbers, like what happens if I try -2? Well, -2 gives me -4, which means -4 should give me, in fact, -2. Or 0 gives me 16, so 16 should give me, in fact, 0. I could do the proof, but I already did one of those, and one of my goals is to keep these videos short. So that's a real quick thing about how to find an inverse, how to check an inverse, graph an inverse, as well as how to prove one. Hopefully that was helpful and didn't take too long. All right, I'll see you soon.